Thanks a ton, Nancy, for that introduction. So I'm really excited to be here tonight and get to share with you some stories about beaver. And some of what I'm going to share with you really is some of the science. Some of this is just kind of some natural history, and a lot of it's common sense. And what is really exciting to me is the beaver have all these lessons to share with us, and they can actually help us better manage our rivers and streams and our watersheds, and they may unlock the keys to, in many cases, actually restoring these systems. Before I go too far, I need to acknowledge a countless number of folks who've made it possible for us to study beaver, and b to share some of these stories with you. There's a whole bunch of folks in our lab, the Etal Lab and Fluvial Habitat Center. Nick Bowis is probably the biggest partner in crime on this stuff, and he's the one who really dragged me out and got me looking at beaver dams in the first place out in eastern Oregon. Whole host of different funders and stuff, and so there's more than are listed here, and we're really indebted to them, and many of them are in the audience here with us tonight. What I want to share with you tonight are these lessons that I alluded to, that we can learn from this little rodent, and it's one of our most experienced ecosystem engineers, and I'll define what that is in a second. One of the things that beaver do is they blur the boundaries between, say, rangelands and uplands and rivers and streams. And that interface across which they blur those boundaries, this, where we might draw a line in the sand, these riparian zones. And so a riparian area is just this area that is the transition between these aquatic ecosystems and these drier, more upland ecosystems, and particularly in arid and semi-arid environments like that which we live in. These are really, really important places. And what beaver do is they come in, they throw in their beaver dams, and this obstructs flow, bumps flows up onto floodplain surfaces, and really expands out those riparian zones. So, this ecosystem engineer, beaver. So, who can tell me what an ecosystem engineer is? Okay, so we got some good guesses. Yeah, yeah. No, that's right. That it's somebody that actually that it's an organism that is modifying the environment, and the reason for them to modify the environment is to make it a better place for them to live. But in so doing, they also provide habitat for a number of other species, and so they are known as ecosystem engineers. And so what we want to do is tonight is kind of understand what is it that beaver are doing in their ecosystem engineering, why are they doing that, and better understand some of the impacts that has on things like flows and water, so the hydrology, and things like the ecosystems that live in these environments. And then we'll get into talking a little bit about the somewhat degraded state of many of our rivers and streams, and this notion that maybe we can take some of these lessons from beaver and use beaver as a restoration agent to fix some of those. And finally, I'll share with you, we'll spend some time going through some mapping exercises and some of the science that we're doing to help better plan for this and develop a realistic sense as to where beaver may be some help versus where they may not. So a little bit of history to start. Beaver their populations in North America are thought to be somewhere in the neighborhood of 60 to 400 million prior to European settlement. If you want a really fantastic history of this, I strongly suggest you read Eric Dolan's Fur Fortune and Empire, which really describes the fur trade and how that led to exploration of the North American continent by Europeans. And it was all driven by this thing, right? What is this? It's a top hat. And it's made from beaver pelts. And so Europeans, this was a sign of status and wealth, and so they had this just insatiable appetite for these furs, and fashion was really driving this thing. And so by the late 1800s, we'd pretty much extirpated most beaver from most of North America. yet enough held on, and their populations have recovered to about 10% of what they were historically. And they are occupying most of their historic range. But it's trappers like this guy, Jim Bridger, who was, one of the main trappers, and where Cache Valley gets its names for the caches where they stored these beaver pelts. Here, this is really what drove a lot of westward expansion, exploration of the continent, and is a deep part of our actually American history. Now, the next thing we need to do is think about beaver as an ecosystem engineer, and really the engineering that they're doing. What's the most obvious thing that they do? That's right, it's they build dams. And so with this in mind, we need to kind of get ourselves into the mind of these little rodents and figure out, well, why are they doing this, and how. The first thing to understand is that beavers don't need to build dams to survive. They are habitat generalists. They're highly adaptable, and we find them in lakes, rivers, and streams, many of which they don't need to dam. We find them on abandoned floodplains and old channels. We find them in wetlands. We find them far north up in the boreal forests of Canada, and far south in the desert southwest. We even find beaver in the Grand Canyon. And the reason they have such an amazing range is because they have really simple habitat requirements. They need water and they need wood. And so up north, you get into a wood limitation once you get up into the tundra, and down south, we get into, because of it being generally drier, we get into water and wood limitations. And this is the notional range map of where we find beaver. Turns out it's wrong. These areas here in Nevada, parts of Utah, and California, actually there's plenty of beaver historically and even today in some of these areas. But this is, generally the sort of range of North American beaver. And so one of the lessons that I think is one of the sort of most interesting lessons from beaver in terms of streams is they are really good at making messes. And so your parents won't like this, but for the kids in the audience, that's right. Making a mess is one of the best things that you can do. Well, at least that beaver can do. And what's so critical about these messes that they make is it makes great habitat for them as well as for lots of other species, both, bugs, bunnies, critters, fish, all sorts of stuff, as well as the flora, so the trees and the vegetation that grow. And this is an area up on Temple Fork. Has anybody been to this? I see a few hands in the audience. This is a site that in 2011, there were no beaver dams. And in 2011, there were a bunch of floods, and a little bit further downstream, it blew out one of their beaver dams. And so they moved, a quarter of a mile upstream here. There was a bunch of aspen and these cottonwoods, and they harvested a ton of them. And in a matter of 3 weeks, they built a dozen dams in this area. Made an absolute mess of the place. And the habitat is far better for it. So why do they do this? Why are they building dams? Well, what's really important to them is maintaining underwater entrances to their lodges. So if you're in a river or a lake or something that's deep enough that they can build a lodge and maintain this underwater entrance to the lodge without having any of without having to build dams, well, then they're absolutely going to do that. But in smaller streams and rivers, here's a river that's not that deep. They come in and they manipulate this to raise the water levels, and so that the first and foremost, it keeps the underwater entrance to the lodge maintained. It also is beneficial where there might be ice cover, and then it can allow them to build up a food cache in the winter, and they build a bunch of storage of this food, which is just sticks, and they can get to it easily from their lodge throughout the winter, even if the pond is frozen over. Now, the family unit is known as a beaver colony. It tends to be somewhere, 5 to 8 in a family, and on average, each year they have 2 to 5 kits. And so, what happens? Beaver are thought to mate for life. And so each year they'll pop out a few kids, and the young will stay for quite a long time with them. They'll raise them up to about 2 years. So here's some little kits, and then as they grow bigger, they take part in all of the sort of maintenance of the colony. And so maintaining the pond, by maintaining water levels in the dam, repairing lodges, building food caches for the winter, digging out canals, harvesting woody material to keep all this going, and they play a big part in that. And then after about 2 years, they're kicked out, and then they disperse off and go and find a place of their own to live, and hopefully a mate of their own. What beaver eat, most of you probably realize that beaver do eat wood. And to eat that wood, they chop down a lot of trees, and so they have these incredibly sharp incisors, and they are growing continuously. And if they don't wear those down, they can actually die from their teeth, just the incisors just growing, 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 and it breaks their jaw. What most people don't realize is just how much of their diet in the summertime actually consists of all sorts of things. Pretty much any vegetables, any herbaceous plants, any leafy matter, grasses, sedges, all sorts of stuff that they will eat. Whereas in the winter, most of their diet is relying on the cambium, or just underneath the bark of woody plant material. There's a lot of folks that think that beaver need aspen to survive. That's absolutely not the case. If they have a choice, they'll definitely go for aspen. To them, it's like chocolate. Just like us, we don't need chocolate to survive, but if we have the choice, sure, we'll have a bite. But they do like lots of different hardwoods, various willows, maples, cottonwoods, all sorts of things. So one of the best ways to kind of get an appreciation of some of the activity that beaver do is actually just to watch a video on this and see some really amazing footage. So this is from Animal Planet. The music is really cheesy. I apologize. But if you listen to the narrator, she's pointing out some good things. Check this out.
Winter is still 6 months away, but this family of beavers can't relax. They've got work to do to get themselves through the frozen months ahead. They need to change this whole environment. They've set it aside for dam building. Rocks and stones form the base, and wooden debris finishes it off. It's a mammoth undertaking, but one that they're more than capable of achieving. A single beaver can move 10 times its body weight per day, almost 500 pounds. Once all the work's done, they'll have a new home. And more importantly, somewhere to store food once the cold spell kicks in. But their food store is no simple affair. It's a high-tech solution, a deep water refrigerator. To construct that, they'll need a much bigger, deeper lake. That means building up the dam at a rate of 5 feet per day. And to increase depth, they dig mud from the river bottom and use it to plug gaps in the dam, making it watertight. After 2 months, the dam has grown to an impressive 300 feet in length, and the pond stretches back over a mile upstream. Now the beavers change tactics. A series of channels are dug out that radiate from the lake to allow easy access to trees and keep the beavers safe from predators like bears. Beavers are actually dog-sized rodents. They're the ultimate lumberjacks, with built-in chainsaws made up of powerful jaw muscles and 4 ultra-sharp incisors that constantly regrow as they wear down. They can gnaw their way through a cottonwood tree 3 feet thick in just a matter of hours. This single beaver will chop down more than 200 trees a year. And most of this wood ends up on the menu. Beavers eat bark and wood, but they'll chop down far more than they can stomach in one sitting. That's where the fridge comes in. The wood is chopped into pieces, dragged down to the bottom of the lake, and pushed into the mud to stop it from drifting away. The beaver family can store almost 150 pounds worth of wood, and low water temperatures keep the wood fresh right through the winter. But not all the wood goes into storage. Once the lake reaches a certain depth, the beavers start lodge building. This multi-chambered shelter, raised above water level, is 20 feet in diameter and houses up to 5 beavers. Come winter, these beavers will have a snug waterfront home in which to raise their young, safe from predators. And with plenty of food available from their easy-access underwater freezer.
So you can see a lot of the sorts of things that they do, just kind of for their own benefit. One of the things the video doesn't point out is that the beaver do actually move around a fair bit, and so they won't typically eat themselves out of house and home. They will harvest a lot of material. It turns out that a lot of the material that they harvest, so in this case aspen, has adapted to that sort of disturbance and responds really well by sending out lots of suckers and lots of regrowth quite quickly. And so they'll work an area hard for 2-3 years, and then they'll let it lay fallow and let it regrow, and then go on and work another area just downstream. So this is an example of that up on Spawn Creek, where some of you may have gone and you can all go and hike up to. These are skid trails. I'm going to show you an aerial photo of some of this just to give you an appreciation of the extent to which they'll go. They're going over a football field and a half away up here. This is about 150 yards away. These are little skid trails which they drag the woody material that they're using to build their dams, their lodges, and their food caches, and drag it back down. Another thing that this shows, this is an area that they're actively working right now while they're letting this one lay rest a little bit. This shows all these dams that they build in series. So sort of like shown in the video, they kind of imply there's just one big pond, but what you tend to find are a whole bunch of these things stacked, one after the other, and that makes it really pretty impressive when you're going along through these things. You just see one right after the other, and why would they go to such effort? Any ideas? Right, so those are some good suggestions. So one thing is easier access to food and to building materials. If you can drag it down a steep slope, that's not so bad, but beaver are slow and very klutzy when they're out of the water, right? They're easy pickings for they're easy prey for any bears, coyotes, etc. that might want a tasty meal. However, when they're in the water, there's hardly any predators that can chase them down. They're quick, graceful swimmers. They have lots of hiding places, and so this makes a big deal. So having a lot of dams in series and lots of little canals and side channels makes it easier to move stuff around. It also is just sort of this built-in insurance policy. If one of the dams breaches or blows out, it's unlikely that they'll all go, and so it kind of gives them some little bit of resilience in that system. So what are the impacts of this dam building activity in the systems that they do decide to modify? Well, one of them that we've alluded to is that the habitat that they make for themselves is good for others also. And some of you may have seen this National Geographic article a couple of years back talking about the sort of reintroduction of wolves in Yellowstone. There's been various controversies surrounding this, but the short of it is elk overgrazed those riparian areas, and there were not beaver in those prior to the reintroduction of wolves. Whatever the exact mechanism, wolves, since they have been this top predator back in the system, the elk are not spending as much time down in the riparian areas, and they have recovered. And so the willow communities and some of the aspen communities there's all sorts of regrowth there. And as soon as that started happening, beaver came back into the system and then modified it even further and made these real hotspots for all sorts of biota. So what else is good about beaver dams? Well, in addition to creating these diverse habitats, the dams themselves are porous structures. Water gets through them, but they act like these natural filters, and so they can improve water quality. One of the things that they do too is that just by physically raising the water level with this obstruction, you're forcing overland flow onto surfaces, and then that water can infiltrate into, and so you get a lot more groundwater recharge. and you're elevating the water tables all around. And then what we see is a real expansion of the sort of riparian areas following these things. They also have pretty big impacts on the hydrology, and I'm going to get into this in a second. But it's not just the water that they slow down. They also change the timing and the delivery of sediment that's carried with that water and nutrients that are carried with that water, and how long that stuff stays in storage. So how does flow change with the dams? We're going to look at this, and what I really mean is how does, if I have a stream and there aren't any beaver dams in here, and it's not a major losing or gaining stream, basically the flow coming into my reach should equal the flow coming out, especially if there's no tributaries coming in. But what happens when I put a bunch of beaver dams in that system? So to answer this question, we first need to make sure we're on the same page about what's flow. So flow is just a volume per time. So classic example, we look at a stream gauge and it reports flow in cubic feet per second. So to measure this, you need a stopwatch basically, and one way you can think about it is a basketball. That's about a cubic foot roughly. So that's your volume, and so how many basketballs can I fit through the net each second? And so that gives us our rate. And so obviously if I have basketballs, too many basketballs all at once, that's like a flood. And so they'll overflow and some of them won't make it through the rim. They'll spill out and flood. So the typical impact that beaver dams have on flow, so just sort of contrasting the flow in versus the flow out here, this is a hydrograph, and this is how scientists measure flow through time. So on the horizontal, we've got time and days here, and on the vertical, we've got that flow concept we just talked about. And so if I look at this blue line, this is the flow coming into my reach, and you can see that there's a couple of peaks, and those peaks represent flood events. And now the green line is the flow at the bottom of my reach. And so one of the first things that you notice is that the flood peaks have been chopped off. So if I focus on this one, this volume of water underneath here has been attenuated. It's been held onto because it's put in these beaver dams. It's spread out over these surfaces. It's infiltrating in the ground, and we don't lose that water. We just see it coming later, and so it holds onto that water later in the season and slowly releases it out. So this can be potentially a good thing for minimizing the impacts of peak flows from flooding, and also it could be potentially a good thing if you want to have water later, say in the growing season. The contrasts that these guys create are phenomenal. Now, this is the same little reach we've been looking at. This happens to be up on Spawn Creek. 2 years ago, there were no beaver dams in this particular reach. The river was over here, and its riparian extent was about here. These willows, which look pretty good size right now, those have all grown in the past few years, and they grew in when beavers started damming this area and expanding that riparian area out and raising those water tables. And so now you have, in this very arid environment, you have this little oasis, and it's bigger than it was before with beaver in this system. And so that's a really nice example. Now, that habitat, it turns out that riparian habitat is important for all sorts of other things, including sage grouse, which get a lot of attention these days because their populations are so threatened. There's some really interesting research just about to be published that's talking about just how critical having these perennially flowing water sources and riparian areas are to maintaining healthier populations of sage grouse and bigger leks, they call them. One of the potential impacts beaver dams could have, say, on aquatic ecosystems is as a barrier to fish migration. Well, it turns out this is a picture of a dam up on Temple Fork, up the canyon. Right there, for scale, that's a person, and this person's actually going through with a mobile antenna and scanning for fish, in which we've put pit tags. And one of the things that we found with after tagging thousands of fish is that the fish are getting upstream and downstream of these dams without any problems, especially the native fish. They do actually a better job than some of the introduced fish, so the cutthroats, for example. And while there are great bumper stickers that say beaver taught salmon to jump, and there's maybe some tiny bits of truth in that, this is not the typical way beaver, or the fish are getting over beaver dams. Fish are sometimes, we have video of them swimming through the interstices of the voids in the dam. And probably most often they're using the overflow side channels as little fish ladders that are for a nice easy path to get up and past these potential barriers. Now, everything is not always rosy with beaver. There's no denying that in some places beaver are an absolute nuisance and a headache. They can cause flooding. They can block culverts. They can chop down ornamental trees that we've planted, and they can certainly make a mess of irrigation diversions and irrigation ditches. There's a whole bunch of living with beaver strategies, and the starting point with a lot of this is to make sure just because a beaver is there and near some of this infrastructure, is it a real problem or a perceived problem? If it's real, the most common response has been to lethally remove these beaver. What typically happens is more come back in their place. There's usually more, and some better techniques are these living with beaver strategies, things like beaver deceivers, pond levelers, caging trees. And so a beaver deceiver is nothing more than some fencing around a culvert that just deters them from building a dam right on top of the culvert and plugging the culvert. And instead they build it just upstream of that, and then there's plenty of space for it to get in there without debris clogging that thing up. Similarly, a pond leveler, this allows beaver to keep building their dam as high as they want, but the water level won't get up to the brim of that dam. Instead, it just goes to the height of the culvert, and you can maintain a safe water level without flooding. And so a lot of these things are described. Mike Callahan's site, Beaver Solutions, has got some nice examples of these. And there's even some examples around here. We've been working with the city of Logan and Walmart actually on Spring Creek. Walmart had to set aside this area when they built the Walmart 6-7 years ago, and they had to set it aside as a wetland mitigation. Well, the beaver have come in since then and made this a far more productive and far richer wetland than you ever could have imagined a civil engineer trying to do. And there is the potential for this to cause flooding and damage to the road. And so we've come up with some plans with the city and with Logan to address those potential concerns and use these living with beaver strategies to mitigate for them. Now, so we've talked about some of the impacts of the ecosystem engineering that beaver have. Now, some could be problematic in certain areas, but a lot of those things are positives. Those are positive impacts. And so when we look to Utah as an example, we have over 85,000 miles of streams and rivers in this state. And that's shown here. It turns out the dark blue ones are the perennial ones. These are the ones that flow year round. And the rest of these are either artificial canals and ditches like the red ones, or they are intermittent and ephemeral, so they only flow seasonally or when there's a big rare storm. Historically, beaver were everywhere throughout this perennial network and probably even extended into much of the intermittent network. And today, at least 43% of all of these rivers and streams are seriously impaired in some way. And this is a massive amount of mileage of streams. And so there is there's a pretty big river restoration industry. And if you do a Google search on for images of stream restoration, the first ones that come up are pictures of Tonka toys, big heavy equipment where folks are trying to re-engineer and rebuild channels and trying to fix them and trying to improve them. And there's this is all good intent. However, this is extremely expensive, and so as a result, most projects cost somewhere between $200,000 and $2 million. And a big project is 2 to 5 miles. Most projects are a couple hundred yards of stream. And so the real take home here is that how many miles of stream did I say were degraded? What, 40% of a hell of a lot of miles, right? 16,000 miles. There's no way, given all the money we might want to throw at this, that we can necessarily fix these systems with all that, with Tonka toys. The other thing is as we study streams and rivers and we learn more about them from a physical, sort of the geological, geomorphic perspective, and the habitats that are created, combining understanding the hydrology and the ecology of these things, we've learned that streams that are dynamic are healthier, i.e., streams that are allowed to flood, streams that change through time, and have some variation. They have more diverse habitats, and that supports higher rates of biodiversity. Yet the irony is, with all the Tonkatoy approaches, we're really not good at restoring dynamism. We're good at, making a static channel that doesn't move, but we're not good at making it messy. And that's what beaver are good at. And so that's what gives rise to this notion, this idea of, letting beaver teach us these lessons and have them help us restore things. So, some things to think about with regards to that. First, this ecosystem engineer has far more experience than most are professional engineers. Because I used to work as an engineer, I can make fun of engineers, but we have what, a couple thousand years of engineering experience. This thing has probably 40 to 80,000 years of dam building experience. So they've got a little better track record than we do. Most of the species also that we are so obsessed with trying to protect, beaver aren't one of them, by the way. Most of these, like salmon in the Columbia Basin here, maybe cutthroat trout, sage grouse, all these things, they co-evolved with lots of beaver in these systems. And probably the most compelling argument in sort of pragmatic terms is the cost. Beaver could potentially do much of this for free. And there's definitely some planning and some logistics that go into this, and there is some cost, but it's far more efficient than the sorts of restoration that we're doing now. The popularity has also been growing rapidly over the past decade. We've seen all sorts of TV and news and radio coverage, etc. Here's an article from the Wall Street Journal a few years back, and it's describing how ranchers actually want beaver back on their ranches because it helps keep streams that would otherwise go dry in droughts. It helps keep them flowing year round. It also can help raise those water tables and produce better forage for cattle, better grass for the cattle to eat. So there's a whole bunch of interesting stuff. But one of the things I like to remind people of is just because we've all gotten excited about this now, and there's a bunch of scientists, pencil neck academics like myself trying to study these things. This is not a new idea. This is an idea that's been around since at least the early 1900s. This is an example from 1950 in Mechanics Illustrated, where they're reporting on Idaho Department of Fish and Game parachuting beaver in to mountainous areas, and the reason is to improve trout habitat and to minimize damage from floods. And so this beaver here is a beaver named Geronimo that they actually, in perfecting this method, dropped over 17 times, perfecting this design for a crate that when it was in the air, the crate's closed, the beaver's in it because the parachute's pulling taut on it, and when it lands, the box opens up and the beaver can crawl out and go do its thing. And may seem silly, but this actually worked. In 1948, they took 76 beaver that were causing trouble around McCall, where people after the war are starting to buy up and get little vacation homes up at Lake McCall in Idaho. They only had one casualty, dropping 76 beaver in. And years later, the beaver, came in and did exactly what they were hoping they would do in the areas they parachuted them in. After the war, you had a bunch of paratroopers with too much time on your hands, and there were parachutes. There were a bunch of surplus parachutes and planes, so it was dirt cheap for them to do this. And there's a great little NPR piece you can listen to. All of the slides are going to be available online, and a lot of the things I'm talking about, there's links that you can go to on the slides if you're interested in hearing more about some of this stuff. So there's three types in general of restoration you can think about using beaver. One is to, just like we described, transplant nuisance beaver. Now, it doesn't all have to be done by parachutes, but some of the things that we have learned are that if you live trap just a single beaver and take it out, it may not stick around. You have a lot better luck if you can live trap the whole colony, the whole family unit, and you move them together. Also, you want to do it about this time of year, early fall, and into the fall, and that's when they're going to maybe start building up their dams and getting prepared for the long cold winters ahead. Um, some have found too that if you make things easier for them, you build a little starter lodge or maybe even a starter dam, that can have a big difference. And this is a bumper sticker from up in Washington from the Methow Valley Beaver Relocation Project, increasing stream complexity one beaver at a time. And they've translocated literally hundreds of beavers, and they've absolutely transformed some of the landscapes up there. The Yakima and the Washington Department of Fish and Wildlife have also been doing a lot of this, and so pretty neat. Another type of restoration, other than the transplanting, is to just promote and protect beaver where they are. If you've already got a source population, just keep that good thing going and encourage that. And so another thing, that this is a nice little anecdote from Curtis Creek, which is up at Hardware Ranch, up Blacksmith Fork Canyon. And this is a place where the Division of Wildlife Resources came in, and this area was pretty heavily grazed by elk, and the stream channel had been straightened, and so they came in with the Tonka toys and made a meandering channel and put in some structures and sort of tried to improve the habitat, and it did to a certain extent. But then a few years later, some of the riparian vegetation started recovering, and the beaver came in, and they thought, I can do a better job. So I like to think of this as accidental restoration. This wasn't planned. They weren't trying to promote the beaver. Beaver just came in and put in these huge dams, created these massive wetlands, just completely modified this place and made it 100 times better than the restoration project that was there. And that's kind of a neat little anecdote. Finally, there's the third type of sort of restoration with beaver is in situations where it's harder for beaver to get started. Or, for example, in incised streams where you got a big, deep incised ditch. We've been playing a lot with using what we call beaver dam analogs to give them a head start. And these are just, we take wooden fence posts and we drive them in, and we'll make fake little beaver dams that'll act like a little beaver dam. And then beaver, in a matter of weeks or months, will come in and start using these and start building on them, and they always do a better job than we do. Some of their dams, particularly in areas where, say like here, there's a bunch of coyote willow, but there's no real big trees, and so there's not a lot of big material to sort of withstand floods, and so the posts seem to buy them a little bit of time just reinforcing existing dams. We've been doing a lot of these with different ranchers, and the ranchers are excited to get beaver back in some of their systems, not just because it's good for the stream and the riparian areas, but because this can provide more reliable water resources, watering holes for their cows, and it can sub-irrigate the valley bottoms, and that will make for better forage production for their cattle. There's a lot of different guidelines and stuff out there on this, and so one of them is the Beaver Restoration Guidebook, and so again, links to these are in the slides. So the last thing I want to talk to you about is where could we apply these lessons, and this is some of the science that we've been working hard on. We have a tool we call BRAT, it's the Restoration Assessment Tool, and really it's just a mapping tool to help assess where dam building activity from beaver could be useful versus where it's problematic. And we've run this in a number of areas. I'm just going to share some results from here in Utah. We've actually run this for all 16,000 miles of those perennial streams in Utah. And the color scheme, I'll explain in a moment here. What BRAT really is it's trying to estimate the capacity of dams. How many dams could the river support, not how many beaver could it support. And it's because the dams are actually what we're interested in. That's the ecosystem engineering that the beaver do that have all these positive impacts. Whereas we can find beaver in a lot of big rivers and lakes where they're not going to be building any dams. So this output that we'll look at, one of the things in the maps will just be how many dams per mile can we fit. And red will be none, and blue we can have as many as 26 to 65 dams per mile. We've actually measured this many dams. It's crazy. And then everything in between. So we'll zoom in up here for our little example from the Logan River watershed. And if you want to play with this in other places, we've got some computers set up afterwards, and you can zoom in to different rivers and streams that you might be familiar with. But here we've got 436 miles of streams. Here's Logan. There's the Bear River Range, the Wellsvilles. And we got 436 miles of perennial streams in the Logan River, Blacksmith Fork, and Little Bear River. And so you run the model, and this is the output you get. So remember that color scheme. There's a bunch of places that can't support much, and a bunch of places that can support quite a bit higher dams. If you add all this up, it suggests that we could fit 7,400 dams in this landscape with existing conditions. That's an amazing number of dams. How many dams do you guys think are out there right now? Yeah, 50, 100, couple hundred. Well, it turns out there's over 1,300 dams in this landscape right now. This was actually a census back in 2012. And fortunately, where we're seeing a lot of the dams are some of the areas where we predict some of the highest capacities, and we're not seeing any dams in areas where we predict you can't find dams, and so that's good. We do find some problem dams. This is done by Walmart, and we got to keep an eye on those. But we've got a truly a large capacity. And so the current capacity is about 16 dams per mile, yet we are only utilizing, the beaver are only utilizing about 3. While we may not expect them to get to 100% capacity, they could certainly get a lot more. So at least 50% of capacity. Right now they're a little less than 20. Another thing we've done is we've tried and model where are the potential for these human beaver conflicts. And so we've got a high probability if you're close to roads, culverts, bridges, railroads, canals, etc. And so anywhere where we've got roads, we've got a lot of roads up in Forest Service land, and then obviously Highway 89 going up the canyon. A lot of irrigation ditches and stuff, and a lot of urban development down here in the city. Those areas have higher probability for conflict. And then areas where we don't have those things, there's a lower probability for conflict. This is probably overly conservative, but it's at least a start to flag up the potential negatives. And so if we take those capacity estimates I showed you, what did we say? Something like 7,000 dams. And we combine it with this, we can start to come up with areas of the stream, these pink, green, black ones that are potential restoration zones versus areas where it can support beaver, but you might have conflicts and versus areas that just aren't suitable at all for beaver. And so if we look at that, there's different questions we can ask of that, like where might I want to try and restore, to restore habitat. But another really compelling and really pressing question is this question of snowpack. And so we've got a declining snowpack, and could we actually get enough beaver dams back on the landscape to mitigate this? Probably before this evening, you would have laughed me out of the room with this sort of suggestion. But when I tell you that you could fit and support up to 7,000 beaver dams, that's a lot of potential hydrologic impact. And so we're trying to quantify these things. We're working with the Forest Service. We've got a grad student that's working on this, Conrad Hafen. He's here tonight. And this is sort of, where things have been historically. This area, this is Logan, the Logan watershed. 90 to 100% of the precipitation that we got was in the form of snow historically. This is changing. We're seeing this already in the past few years. This is what's projected for 2035 to 2065. Look at how little of our of this area is actually predicted to be precipitation in the form of snow. Most of it's going to be rain. Rain's going to run off much quicker. And so we're trying to see if we can get enough beaver dams back on the landscape and just trying to see if that could actually work. If you clip down that management layer to just the areas with restoration potential, it's quite interesting. A lot of these are in precisely the zones that are most vulnerable to losing some of that snowpack. And, there's only about 664 dams in those areas now, and we could have up to 4,200. So we think that this is a problem that's at least worth exploring, especially considering the cost. There's lots of other reasons to use beaver as a restoration agent, but we think this water resources question might be a really exciting one. And obviously we've got a bunch of beaver in places that they could cause harm, so there's probably no shortage of nuisance beaver. So we're running this in other states. We're playing lots of games with this, using this as a guideline for driving restoration decisions. If you want to interact with this stuff, there's a website that you can go to, and like I said, we have some of this set up outside if you want to play with those things. So to wrap up here, my take-homes are that you should go away realizing that beaver are an amazing ecosystem engineer and potentially a really good partner for restoration. their dam building activity and making a mess of streams makes a lot of great habitat for a lot of others. And we're just starting to really explore at a bigger scale the hydrologic impacts. We kind of understand what those things are at a local scale. But one of the surprising things is just the capacity of these landscapes to support dam building activity by beaver. There's a lot more that could be done using beaver. They aren't the solution everywhere, but some places they are. And so some of our science aims to better quantify and predict and map these impacts. Some of it seems like death grips on the obvious, just quantifying it. And then others of it are really kind of exciting, frontiers. And so hopefully that's of some interest to you, and I'd be more than happy to answer any questions you have. If you're curious about this stuff, there's a couple of really fun books. Enos Mills and Beaver World and the Beaver Manifesto. There's also a number of documentaries. I've got links to these things, and whoops, and a lot of websites and resources. So thank you very much for your attention, and I'll take whatever questions you have.